We are live. Hi everyone, welcome back to Code Era. So today is the fifth session of this mastering greedy problems of CodeForces. You can just quickly give a +1 in the chat, and you can just like the video if you haven't already, and then in a short time we'll begin with the session ahead. I'll just wait for a couple of minutes for everyone else to join, and then immediately after that we'll begin with the greedy problems. Whoever is watching currently, you can just give a +1 in the chat, or you can like the video so that I know that everything is working fine and we are good to go. So as usual, as we have been doing for the previous 4 streams, so we have these 3 problems that we'll be discussing: road to zero, then yet another bookshelf, and minimum product. So we'll be reading these problem statement, we'll be learning like how we have to actually do them, and after that what we'll be doing is we'll be writing the code for all these problems. Okay, so hi Ria and hi Sethi. So great. I'll just wait for 1 or 2 minutes more so that others can join, and after that we'll begin. But first of all, first things first, just quickly tell me in the chat like how many questions did you solve yesterday? How many competitive programming questions or DSA questions did you solve today or yesterday? Or let's say today. How many questions did you solve today? How many DSA questions or CP questions did you solve today? Just comment down below. Just quickly comment down below. After that, I'll immediately begin with the session. Okay. I'm still waiting for your answers. Also one more thing, like I gave 3 problems, so did anyone try these problems? And if you tried, so how many problems were you able to solve, and which problems were there in which you felt that there's some issue or there's something that you were missing? So you can just write that I give today's lead code contest and some of greedy questions too. That's great. Try to be consistent. That is the key for mastering DSA and CP. Greedy 2, lead code contest 3 questions. That's great. Okay, perfect. So right, so without further ado, let's begin with the first problem. So the first problem is named as road to zero, and just let me zoom in a little bit. So the first problem, which is named as road to zero, it is a problem A. It was asked in CodeForces educational round 86, rated for division 2, and what it says is that you have been given 2 integers, that is x and y, and you can perform 2 operations. Implement it, but I need to see tutorial because I did not get questions. Yes sir, एक नहीं हुआ आज का, second submitted. That's great. So you have been given 2 integers x and y, and you can perform 2 types of operations, right? So you can pay $a and increase or decrease any of these integers by 1. So what you can do is, let's say you pay $a, right? You pay $a. So you have been given 2 integers. One integer is x and the other one is y. What you can do is, there are 2 types of operations. In the first operations, what you can do is you can pay $a or a rupees. Okay, you can pay $a, and what you will do is by paying these $a, you can either increase or decrease these values, any of the x and y, by 1. Okay, this is what has been written. You can increase or decrease any of these integers among x and y by 1. आ रहा था इसका. Okay, so we'll be discussing them, no problem. Now let's say if x was 0 and y was 7, so there can be 4 possible outcomes. That is, either I can decrease x by 1, or either I can increase x by I can what I can do what, right? If there is this, so by paying $8, what will I do? By paying $8, what will I do, right? By paying $8, what will I do? So let's say I am here, right? One. So what will I do? By paying $8, either I can increase x by 1, and I can keep the x same. I can increase y, I can decrease y by 1, and I can keep y same. And then I can also do this, I can keep y same and I can increase y by 1, x same and y by 1 increase. Then I can keep x same and I can decrease y by 1, right? These are the four type of moves that I can do by paying $1, right? Now let's move to the second operation. So the second operation says that you have to pay $b and you have to increase or decrease both the integers by 1, right? So you have to pay, in the second chance what you can do is you can pay $b, right? And in that what you can do is you can do an x plus 1 comma y plus 1. That is, you can either increase both or you can either decrease both of them, right? This is what you can do. So this is what has been stated in the question. Let's say if x was 0 and y was 7, so if you increase them by 1, decrease them by 1, both by 1, so it will be minus 1 and 6. If you increase both by 1, then it will be 1 and 8, right? So this is very much clear. Now the main thing is, your task is to make both the integers equal to 0 simultaneously, right? So you want that in the end there is a target that you want x to be equal to 0 and you want y also to be equal to 0 by in the end, right? This is what you want. And another thing is that there are no other requirements, and in particular is it possible to move x is equal to 1 comma y is equal to 0 to x is equal to 0, y is equal to, so ultimately it says that can you reduce both of them equal to 0 simultaneously, right? Now let's quickly move to the test cases for this problem. Okay, so let me just copy the test cases. Okay, so I have copied the test cases. Let me write them here. Okay, just facing some basic issues. Yeah, right, perfect. So let's copy the test cases here, and right, this is copied, and now let me copy the answers for them, right? Okay, and in this question you can notice one thing, that you have been first of all given the x and y, and in the next line you have been given a and b, right? The cost. So you have to find the minimum amount, minimum number of dollars or minimum amount of dollars that you will be spending to make both x is equal to 0 and y is equal to 0 simultaneously, right? Is the question clear to everyone? If the question is clear to everyone, then consider giving a +1 in the chat, so that I know that this much part is clear to you guys, right? And after that only I will begin ahead. Okay, is this much part clear to everyone? So let's say if x was equal to 1 for me and y was equal to 3, what will I do? First of all, what will I do, right? How will I do it? I can definitely take b. Let's say I take a b, right? I take a move from b. So from 1 3 I spend a b, that is 5 5 and 5 555, that is the value of b, which is 555, and the value of a is nothing but 391, right? So from this it will reduce to 1 comma 0 comma 2, right? Since now it is 0 comma 2, so you can very easily see that what will happen with it, right? What will happen with it? You now need 2 into 391, right? Because you will be spending, you'll be making it 0, right? So you will be making it from 0 to 1 and then 0 0, right? So how you'll be doing this? You will be applying this a operation, right? Because you cannot change now, you cannot change a because a is already 0, right? So now let me do the calculations part. So 391 into 2, so what does it what do we get? 8 787, this, and then I add 555 to it, so ultimately I'm getting this number, right? I'm getting 1337, right? So this test case is pretty much clear to everyone. Now let's see the next test case, which is if x and y are both 0, so in that case you will not be requiring any further optimization, right? In that case you will not be requiring any further you will not be requiring any dollar, right? Because you'll be requiring $0 because it is already 0. Why will you require anything, right? Is this much part clear to everyone? If this much part is clear to everyone, then please tell me so that we can move ahead. Okay. Right. How can we approach this question? I want to know from all of you, right? I want to know from all of you. How should we approach this one? How should we approach this problem? Can someone in the chat quickly tell me? How will you be approaching this problem? How will you approach this problem? How do we do this? Is there some way that we can find? Is there some optimal way that we can just solve this, right? Is there any way? Is there any possible approach? Because what you have to do is you have to minimize your cost, right? How should we do this? I want to know from you guys. I want to know the answer or the approach from you. I want your participation now. Just quickly tell me, what should we do? First, try to make them equal by using A, and then use of B, we make it 0. It is my approach. Did you get it accepted? Did you got this approach as accepted? How should we approach this, right? So Sethi has given some answer. Ria, what about you? How do you think that we should be approaching this? What do you think is the correct optimal way to approach this? What do you think? What do you think? What do you think we should do with this problem? How should we approach further? Because I want to know from you guys, like, how should we do this problem now? From here on, how should we approach? Wrong answer in second test case. Okay, that's great. Okay, suppose what you are saying, right? You are saying, what you are saying is that what you are saying is you are saying that try to make them equal by uh, by using a, right? Using a, then make it 0. Make it 0, right? This is what you are saying. Then make it 0, right? But do you think that it will work? Because try to make them equal by using a, right? But you need to think of a lot of cases, right? There can be a lot of situations, a lot of test cases that you are not considering, right? You are just thinking of this test case, but think of a lot of other numbers, a lot of other pairs of x and y to first make them equal, right? Okay, I understand that we can try to make them equal, but what after that? What after that? What after that? Okay, let me tell you one thing. For the sake of simplicity, let's say we are assuming that x is we are assuming that x, which is x is greater equal to y. Okay, I'm initially assuming that x is greater equal to y. Why is that so? You can also assume the other thing, but I'm doing this so that I do not have to write if else, and in this that if else I do not want to write a lot of code. That is why because ultimately I have to make both of them 0, so I can consider one number as bigger and the other one as smaller. Okay, after this, what you will do with this? How will you be doing this, right? So there can be a situation, right? Let's suppose that what can happen, let's suppose that you have some x and you have some y, right? So you can try, but what can happen is if suppose that there can be two situations that you can try to make them 0, right? You can try to use all your a, right? You can try to use all your A, and you can try to use all your A here, right? You can try to, like, whatever is the value A into X, let's do A into X, that is that many number of times we can reduce X by decreasing it by 1 or increasing it by 1, so that we can make it at 0. Another thing that we can do is with Y same, we can increase it by 1 or decrease, we can increase or decrease it 1 by 1, right? So to make it 0, and for that we'll be using using A, right? So if for one chance it is A, it is costing $8, so for X number of times it will be costing X into A. Similarly, it will be causing A into Y, right? So now you take A common, so that will be X plus Y, right? Now this can be one of the possible approaches to make both of them 0, right? So will this be A? This will not be A, right? This will be what? Will this be A? Like, this will be what, right? How do you figure out this? So for this, how do you see that this will work? How do you think? Can you think of this case? That in this case, if you want to make them 0, then either you can apply this approach, right? This approach is applicable, right? Why this approach will be applicable? Because you will simply do A into X plus Y, and in that case you will be able to get your X and Y as 0, right? Yeah, right. After that there can be another situation. What can be the other situation? Other situation can be that let's supposing that X is a bigger number, okay? Supposing that X is a bigger number and Y is a smaller number, okay? This is X, and this is Y, okay? So whichever part, like, from here to here, you want your X from here to here. First of all, X should be equal to Y, right? So for that you will do X minus Y into A, right? Because you will be reducing X this much number of times. Whichever part it is different, it is more than Y, you, for that part you will be using A. You have to use A because there is no other choice, right? But for the joint part, what you can do is, for the joint part you can simply multiply Y, that is this much part, that is this much height, which will be same in both. So you can use B for that, right? This can also be the case, right? Does everyone agree on this? Does everyone agree on this? Just quickly let me know if everyone agrees on this or not. Everyone agrees on this? There can be, yeah. Okay, perfect. So there can be two situations, right? Either this can be the first situation, right? The first situation is that you do this. You reduce both of them using A, one by one. So that means A into X and A into Y. So that simply indicates this. Another situation can be this, right? This X minus Y into A, that is whatever is the difference. You yes sir, I am doing that second approach only. Yeah, right. Right, this is what you are doing. The difference, which is the difference part, you multiply it by A, and the rest of the part you are for the rest of the part, which will be equal, like for this part, for this much part you are using B, right? And for this much part you are trying to use A, right? But how do we know that which approach will be possible, right? Only these two cases can be applicable, right? Everyone will agree that only these two cases can be applicable for any numbers. Now the reason why I'm not taking any numbers, because here numbers are not the concept. The concept is that how do you think in a greedy manner directly, because taking numbers won't help you much. Because if you will just try to brainstorm, then only it will work. Because making some random numbers and then doing, it will not have, because there are not many approaches. There are only two types of approaches that you can do, and you can think you will not be able to get any other approach, because this is very simple, right? After this what should we do? The next question is, what should we do? So if my 2 times of A, if it is lesser than B, then I should approach this, right? If my 2 times of A is lesser than B, right? Because what? Because of this. Because if my 2 times of A is lesser than B, then this approach will be cheaper, right? If this is the case, if I am basically doing what? I am basically doing what? I am applying it 2 times, right? I am applying it 2 times. Okay, so that is why, if this is the case, then in that case my A plus A, right, it will be cheaper, it will cost me lesser, right? And in the other case, in the if part, this will be the case. in the else part this will be the case, right? Because if 2 into a will be lesser than b, then in that case I'll be reducing both individually, by taking a number of a dollars each for all x and a dollars of y for all the y's, right? A dollars for all the y's, right? Other than that, if that is not the case, right, if you add these two and still you are getting is still if you are getting this, right, if you are getting your a 2 cross a, if it is greater, right, if adding a and a two times gives me greater, so that will mean that my a will, by reducing by singly reducing them, will give me cost, right? Y2 into x, right? Y2 into x, because why? Because there are two elements, right? Because there are two elements. If you will see, if you will notice this, so a plus a, what does it mean, right? So what does it mean? So for reducing, let's say I do this, right? Let's say I do this, let's say I have n x and y, right? And if I reduce both of them, so either I can do it using b, I can either use 1b and I can reduce both or increase both, or there can be a situation where I can use a separately and a separately for it, right? It can cost me lesser, right? It can also cost me lesser. This a and a applying, like either I can apply b, right? Either I can, let's say the cost of b is 3, right? Let's say the cost of b is 3, to decrease both by 1, right? To decrease both by 1, the cost of b is 3, and the cost of a is 1, to decrease individually by 1. So that will mean that I'll require 1a for reducing x by 1 and 1a for reducing by 1. So that is why I'll require a plus a, right? So that means that this will be cheaper. So this indicates to me, this simply indicates that doing it individually, individual is optimal here. Individual move is optimal, right? Individual move is optimal, right? Individually reducing is cheaper. Individual is cheaper, right? Individual reduction is cheaper. Individual reduction is cheaper if a 2 times a is cheaper, right? Then you can see that in this case you will get 2, right? You will get 2, and in this case you will pay 3. So which is cheaper? This is cheaper, right? So that is why you are checking. Only then you can say, right, that you will be going for the individual one and not the difference one, right? Are you getting this point? Is this point clear to you? Right, for this you will be paying 2, right? One for the reducing x and one for reducing y, so you will be paying 2. And if you do that simultaneously, then in that situation you will be paying 3. So that means that a plus a is lesser than b, right? So you will want to perform the individual actions, right? You will not want to perform it at one point of time using the operation b, because this is costing you more compared to a plus a, right? Compared to individual subtracting or adding or subtracting individually, right? Is this much part clear to everyone? Little tricky, sir. Like, it is not tricky, let me tell you, it's not tricky, yeah. It's not tricky. Why is that? Why do you think that it is tricky? It is not at all tricky, not too much. It's blur, but we'll understand. It's just a daily life. It's just what you do in daily life, right? What I'm saying is, either you can do what? Either you can reduce individually, right? So how will you say that you should reduce individually? Because you will reduce individually only when 2 times of a, that is a plus a, that is individual subtraction cost will be what? A plus a, right? So this, if this is cheaper than b, then in that case you will say that I should be reducing individually, right? I should be reducing individually, right? Otherwise, right? Do you get this? This is very easy. This is very easy, man. What do you have to do? You have to just see, right? A plus a. Why a plus a? Because if you do individually, then it will be a plus a, that is 2a, right? So for reducing both by 1, I'm saying that we are talking about reduction part, right? If you're reducing both by 1, so you pay 2a. If you are reducing both at one time by paying by b, So whichever is cheaper, you'll be taking that, right? If this is cheaper, if 2a, if reduction by individual is cheaper, so in that case you will reduce individually, right? And if that is not the case, if reduction by individual is not cheaper, right? If individual reduction is costing you more, so in that case what you will do, whichever is the combined part, that part you will be doing what, all that, for that part you will be directly doing that combined, right? By using b, by paying b dollars each time for the y number of times, which is the equal part, right? And for the rest of the part, you will be doing what? For the rest of the part, that is the part that you have to basically you have to do that, you have to subtract it by one only individually. For that part only you will pay, right? Is this clear to everyone? Is this much part clear to everyone? Okay, let's try and write the code for this. Okay, that is why I took such problems, that is why I take such problems. Like, I do not take them randomly. I try to see that is there any proper thing that you will be learning from this. Okay, so let's say long x and y, and let's say x then y then a and b. So I can simply take c in x, and let's say x, and then I take y, and then I take a, and then I will take b. So first of all, I will check that if y is greater than x, so in that case I will swap, because I am assuming that x is greater than y. Okay, so that is why I'll swap x and y. And after that, once this part is done, so I'll check that if a plus a, right? If a plus a, so this is what, assuming that y is greater than x always. Okay, if that is not the case, so you will swap them and they will be right. After that, you will check that if the individual reduction is lesser than b, right? If the individual reduction individual if the individual is cheaper, than combined, right? So if the individual is cheaper than combined, so that basically means that you will be doing what? You will be performing it for both. That means what? A into x plus y, right? Correct. And you will be doing a line change. After that, you will write in the else part, and you will write what? You will simply say that whichever part is common between x and y, for that part I'll be doing the combined one, because I want it to be cheaper. And whichever part is common I'll be doing for that, and after, like, whichever part is common I'll be paying b for that, and for the rest of the part I have to pay a, because I have no other choice, right? Let me just quickly copy the test cases and see if this works or not, right? Let's copy this. I can see a lot of people alive, so you can just consider giving a +1 in the chat. Okay, you can see that it got accepted, right? So this got accepted. Now let's quickly move to the second problem. What is the second problem for us? The second problem, which problem should I take? Should I take this one or this one? Both. Let's take this one. Let's take only the yet another bookshelf one. Okay, so yet another bookshelf. So the problem says that there is a bookshelf and there are n books in it. Okay, so in this bookshelf there are n books, and the ith position of the bookshelf is ai is equal to 1. Okay, the ith position for this is ai is equal to 1, and if there is a book on this position, right, if there is a book on this position, then it is 1, otherwise it is 0. Okay, it is guaranteed that there is at least one book on the bookshelf. Okay, in one move you can do what? In one particular move you can do what? In one move, okay, yes sir, got it. In one move you can choose some contiguous L and R, and consisting of books, that is I I from L to R condition that AI is equal to 1 holds. You can choose them, you can choose some contiguous segment, okay, and you can shift it to the right by 1 and move the book at the index I to I plus 1 for all the i's in this range, okay, and this move is done right after done only if r plus 1 is less than n and no other position, okay. Your task is to find the minimum number of moves you require to collect all the books on this shelf as a contiguous segment, right? What does it mean? What does it mean? Let's see this problem. Like, it's not very clear from the problem statement itself, right? But let's see what it looks like. So your task is to find the minimum number of moves in which you can collect all the bookshelves as a contiguous segment, okay. So what does it mean? Let's say if you have been given 0 0 1 0 1, right? If you have been given this, so where is the gap? Where is the gap? The gap is here, right? If this is the gap, right? So how will you fill it? For this, like, this is the gap. Let me show you. Yeah, like, this is a very easy problem, I would say. Okay, so let's say there are zeros, there is 1, there is 0 and 1. What is the gap? What is the gap? By what is the minimum number of moves that you will require to bring all the shelves which are having books together? What is the minimum number of moves for this test case? It will be 1, right? It will be 1. For this it will be 0, because all the bookshelves which are containing books are already uh, together, right? Contiguous. Now let's say if all are 0, right? If all are 0, we have to remove gaps from the books. Yeah, that is what you have to do. Let's suppose that this is all 0, right? This is all 0. If this is the case, then in this case what will happen? You require no moves, right? Because there are no such thing that is different, right? If there is only one here and all others are 0, then also you require 0 moves, right? So these are some of the cases. Let's say if this was the case, 1 1 0 0 0 1, so in this case you will require 3 moves, right? But how do you actually get it, right? How do we actually do it in such a way that it's optimal, right? First of all, like, let's take some of the sample test cases and let's quickly try to see what we can do for this problem, okay. Let's quickly try and see what we can do for this problem. Okay, perfect. Let me just copy the samples and the sample answers. Okay, let's say if you have been given 0 0 1 0 1 0 and 1, okay. Let's say if you have been given this, what will happen with this case, right? What will happen with this case? You will see that first of all, let's say what will happen with this case. So you can do what? You can move it here, you can move this one here, and you can move this one here. So in this way you take 2 moves, right? You take 2 moves. That is perfect. Now let's look at the next case. 1 0 0, so you take 0 moves, right? Because you don't have to combine anything. Now let's say you have this 1 1 0 0 and 1. So for this how many moves? For this 2 moves, okay. After this, let's say 1 0 0 0 0 and 1. For this you take 4 number of moves, right? And for this 1 1 0 1 1, you take how many moves? You take 1 move. Can someone tell me how we should approach this? How we should approach this exactly? Like, can someone tell me what is the optimal approach? What is the optimal answer? Or how should we think about this problem? From here onwards, how should I think about this problem, right? How should I be thinking about this problem? Can someone in the chat quickly tell me about that? Just quickly. How should I be approaching this problem, right? How should I be approaching this problem? Can someone in the chat tell me? This is a very basic problem. One move, how it is? Did I write one move? Yeah, one move. Why? Because it has been written in the question. One move. How? I'll tell you. No worries. It has been written that shift to right. Okay, you can choose any contiguous segment of L and R which is consisting of books. Okay, you can choose any contiguous segment, right? So in this what will happen? 1 1 0 1 1. Okay, so you will choose this whole. You will choose this whole, and you will move complete by this. Okay, so this will look like this. You'll move complete contiguous segment. Okay, let's say if this was 1 1 0 and 0 and then triple 1. Okay, so you'll move all these triple ones. You will collect all these bunch of threes, and you will take two moves, right? You will take two moves towards the left, one move, then the second move. Okay, then 1 1 1 1 1 1, right? This is how it will look like. Is this clear now? I hope that it is clear. You can move contiguous segment of ones. You can move contiguous segment of ones, right? Okay, is this part clear to everyone? Is this much part clear to everyone? Then only I can consider moving ahead. Shall I move ahead? Shall I move ahead? If this much part is clear, then shall I move ahead? I'm still waiting for your replies. Shall I move ahead? Right. What we should do, right? What we should do. Now let's take some random cases quickly, quite quickly. Okay. So one thing that can happen is you can notice that all the trailing zeros, right? All the zeros. Let's say here is one, here is all these zeros, right? And in between, what is happening? In between, anything will be happening, right? In between, there can be anything. Okay. There can be x y z, x y z, a b c d. In between, there is whatever we I don't care. But all these zeros which are here, I will not need to consider them, right? And all the zeros which are here, I also don't need to consider them, right? Everyone agrees on this. Everyone agrees on this. Now let's say that I have 1, then I have 0, then I have 0, then I have 1 1. Let's say I have 0 again. Let's say I have 1 and 1 and then a lot of zeros, right? A lot of zeros here and a lot of zeros here. I will not consider these zeros, right? There is a pattern. Count the number of zeros in ones. Yeah. What I will be doing is I'll start an I from the start, and I will see if this is a 0. I will move ahead. I will come here. I will see that is this a 0. Yes, this is a 0. So I'll move ahead. So now my I is here, and I can see that here I have a 1. Okay, so I'll stop here. Okay, similarly I'll start from the back. I'll start from the back, and I'll initialize my j. So initially my j will be here, and I'll say is this a 0? Yes, this is a 0. So I'll move ahead. I'll do a j minus minus. I'll move. Then I'll move here. Then I'll move more, and then I'll see that again it is 0, right? Now I'll move here, and I see that now this particular j point is pointing to a element which is 1, right? Which is 1. Now what I need to do? I can safely say that I can safely say that I can choose this particular segment, and I can move it here, right? I can move it here. So this will be what? 1 1 1 1, right? Similarly, I can say that I can choose this number. I can move it by two elements, right? I can move it by two elements, right? So this will mean this will be looking like this, right? So you will say that these two zeros and this one zero. Ultimately, from wherever you will point your eye to the first value, your eye, what will you be doing is, what will you do? Your eye will be pointing to your first occurrence of 1 from the start, and j will be pointing to first occurrence of 0 from the start. Okay, this is what you will be doing. Okay, now in between those indexes I and j, in between that particular index, in between all those particular indexes I and j, in between those particular indexes of I and j, okay, the total number of zeros that are there in between those particular i's and j's, I am not considering all the except this array. I am not accepting this much part, this much zeros part, right? I am saying that all this much part now will be all the zeros that I get in between. I'll count them and I'll simply print them. Okay, all the zeros in between which I am getting, I'll simply count them and I'll print those number of zeros, because that will be the number of times that I have to shift my contiguous segments. Okay, so is this part clear to everyone? If this much part is clear, then please consider giving a +1 in the chat. Please give a +1 in the chat if this part is clear to all of you. This part is clear to all of you. You can take some random cases and you can try it yourself. Okay, clear. Okay, clear, right? Let's quickly write the code for this problem as well. Okay, let me see what is the input format. First of all, it says n and then the array. Okay, perfect. Right, let's write the code for this without wasting much time. Okay, so what I will do is I'll take n and I, and initially I will take count, or you can say moves. Okay, I will say moves, which will be initialized to 0. After that, what I will be doing is I'll also need a j, right? I also need a j which will be pointing to the end. Okay, after that, what I'll do, I'll take n as an input, and once I take n as an input, so I'll declare a long array n, and once I'm done with this, so I'll take the array a as an input. I starts from 1, I is less than n, and I less than n and I plus plus. After that, I will take my array of I as an input. Once I take that, so I'll start from the beginning, right? I have initialized, notice that what I'll do, my I will be initialized to 0 and my j will be initialized to n minus 1, because my I will be starting from the first index and j will be starting from the last, right? So I will check that while I is less than n, okay, while I is less than n, I will check, okay, I'll check what, if my a of I is equal to 0 for that particular I, then I will do an I plus plus, right? Otherwise, else I will break out, because that will be the index from where my contiguous one segments are starting. That will be the first occurrence uh, uh, of one in this from the starting, right? Similarly, what I will do, similarly I'll do it for j. So j starts from, j is greater equal to what? J is greater equal to 0 basically. Now I will say what, if my a of j, if my a of j is equal to 0, so in that case I'll do a j minus minus. I'll keep on decreasing my j because I am moving from the back, right? I am moving from the back. Otherwise I'll simply break, indicating that that particular j points to the first occurrence of 1 from the beginning, right? This part is clear. Now I can run a loop more. Let's say int k. I'm taking k, you can take any variable. K will be starting from 1 and k is lesser equal to j, right? The first occurrence of 1 and the last occurrence of first occurrence of 1 from the beginning and the last occurrence of 1 from the end, that is j. Now I'll be doing a k plus plus. After that what do? I simply do one thing, and that is if a of k, if my a of k is equal to 0, then I simply do a moves plus plus, right? This is what I will do. Now next step, in the end I can simply print the number of moves. Okay, then now let's do an endl, right? Let me quickly copy the test cases so that we can see that whether this code works or not. Okay, is this part clear to everyone? Is this much part clear to everyone? Clear, sir. Okay, it is giving some segment error. Why is that so? Let me check. I'm doing a k plus plus, then I'm doing a moves plus plus. Why am I getting a segment error on this? While I is less than n and j is greater equal to 0, I do a j minus minus. Right, this is what I will do. I'll take it as an input. Once I do that, j will be this and this will be this. Okay, I think that I've made some mistake anywhere. I think here I might have made some mistake. So let's try and run it again. If this gives an error, so I'll check segment error. Why is it giving a segment error on this? Let me just quickly check it. So I'm getting c in n. I have taken long n, and then I have taken the complete array as an input. Okay, I'll need to initialize my I to 0 here as well. Okay, because my I, since my I was moving, right? Because since I was running a loop, that is why. Now it will give me the correct answer, because I was using I for that, so that is why this was happening. Okay, am I getting another error? I don't think that I will be getting an error. Let me try and submit. If I get some error, then I will check. Right. Let's just check whether this works or not. It will give some runtime error only. Okay. Let me see where I'm getting a runtime error. Initialize my I to 0 and j to n minus 1. Yeah. Basically the thing here is that j has not been taken as an input up till now, right? So when n has not been taken as an input, so that is why I will do this, right? I have to do this because I didn't take n as an input and I initialize my j to n minus 1, right? So this is why I was getting an error. Okay, this is why I was getting an error. Okay, I'm still waiting for your replies. Just let's see if this works or not. It's giving a compilation error. Okay, so it will definitely give a compilation error because I have not declared j. Now it will work. Now it will work for sure. Let's try and submit it after some silly mistakes that happen sometimes. You can see that this problem also got accepted, right? So this is the code for this problem. You trim out all the starting zeros and the ending zeros, and whichever zeros are there in the middle, you simply take them, right? This much part is clear. Now let me just remove this part from the problem. Okay, let's move. ये मुझे भी बहुत बार हो जाता है. Yeah, right. That happens sometimes. Such things they can happen sometimes. Okay, let's not worry too much about them. Okay, now let's move to the next problem. Okay, let's move to the next problem and see what the problem has to say. So the next problem is nothing but next problem is minimum product. The next problem is named as minimum product. It was a problem B for a diff 3, and it says that you have been given 4 integers, that is a, b, n, x and y, and a is greater or equal to, let me write the information that has been given to us. First of all, it says that you have been given you have been given 4 integers a, b and x and y such that a is greater or equal to x, b is greater or equal to y, and what it says is you can do no more than n operations. Okay, you have also been given an integer n. Okay, and you can do not more than n operations, so you can perform maximum of n operations. Okay, maximum of n operations. Let's lead the problem further. It says that you can choose either a or b and decrease it by 1. Okay, you can choose either a or b and decrease it by 1, and however as a result of this operation, a cannot become less than x and b cannot become less than y. Okay, you have to find the minimum. Your task is to find the you can do what in one move. You can decrease a by 1 or you can decrease a by 1 such that it cannot become less than x. Okay, so when let's suppose that a is there, so if a is greater than x, so that a cannot be less than x. A has to be, the minimum value that you can reduce a to is x, and the minimum value that you can move y from, you can decrease y to is, you can keep on decreasing b, and it should not be below y, right? Once it reaches y, so after that you will not be decreasing it any further. You have to find the minimum product of a and b that you can approach that you can get by applying these operations. Okay, you have to find the minimum product. How should we do this problem? How shall we do this problem, right? You have to find the minimum product of a and b, considering that you can not perform this operation not more than n number of times, and n has been given to you in the problem itself. Okay, right? Is the question clear to everyone? If the question is clear, then please give a +1 in the chat quite quickly so that we can move ahead. Okay, shall we move ahead? If the question is clear, so shall we move ahead to the solution part of this problem? Shall we move ahead? Shall we move ahead? And can you think of something? Same, ये मुझे बहुत बार हो जाता है. Yes, okay. Perfect. Let's move ahead. Okay, what we can do? let's say if you have been given a value that is 10. Let me just erase this much part for some space. Okay, let's say you've been given 10, 10, 8 and 5. Okay, and you can perform 3 moves. This is your X, this is your Y, this is your A, this is your B. So you can maximum you can reduce A is 2, maximum that you can reduce B is also 2, right? And not 2, 5, but 5. Okay, how do we do this problem, right? How do we do this problem? How do we do this problem? Can someone in the chat tell me, like, how do you approach this problem? Let's suppose it came in your contest, right? How would you approach this problem? What will your approach be like? How do you approach this? If A is bigger than B, then we first start reducing A, otherwise B, until A is greater or equal to Y and B is greater or equal to Y. Yeah, right. Right. So what you are saying is that whatever are the number of moves, you will try to think in a greedy manner. Okay, you will try to think in a greedy manner, and simply what you will do, you will try to first reduce the bigger number, right? We are assuming that A is greater or equal to B. Okay, for the sake of simplicity, we are saying that, let's say A is the greater number, right? So in this, you will do what? You will decrease the number, and you will decrease it by what? If you have A, let's suppose if you have A, right, and if you have B, so which number A cross B, why will A cross B be greater? A cross B will be greater when this number is bigger, right? So you will try to reduce it, right? So first of all, you will try to reduce it, and once both are equal, so you can now reduce each other, right? Like you will do A minus minus until A is equal B, and after that you will reduce both by 1 if you have the moves, right? Is this much part clear to everyone? Is this much part clear to everyone? Right, is this much part clear to everyone? Is this part clear to everyone? Is this much part clear to everyone? Clear, okay. What about others? What about others? Just quickly tell me. What about others? Is this part clear to everyone? I want the answer from everyone. I want the answer from everyone. What about others? Clear, okay. Shall we move to the code part of this problem? Shall we move to the code part of this problem? I'm still waiting for your replies, man. Right. Okay. Let's move ahead. Let's move ahead. Let's move ahead with this problem, okay? What does this say? Let's see what are the inputs for this problem. Yeah, right. What should I do? First of all, what should I do? I'll take a long A, B, X, Y, and let's say N, okay? Once I have these variables declared, I have not done this right this, okay? So then what I'll do, I'll simply C in A, then B, C and D, right? This is not A, B, C, D, A, B, X and Y, right? This is what I'll be doing, right? Once I'm done with this, so let's say I make a function, okay? Let's say I make a function calc. I'll make a function calc in which I'll be passing all the parameters a, b, x, y and n. Okay, I can do this for both the variables. Like what I'll be doing is I'll be telling you a comma, let's say this will be what, this will be b comma a comma x comma y comma n. Okay, x comma y comma n, not y comma x and then n. Okay, uh, um after that, let's say this is long, let's say this is nothing but long answer 1. Okay, and let's say this is nothing but long answer 2. Okay, so in the end I'll print the minimum answer. Okay, why am I trying to do it this way? So you will just understand once I tell you about the function. Okay, once I tell you about the function, so you'll be very much clear about it. What we'll be doing for this is I'll be making a function that is long calc, which will be calculating what it will be calculating. So I'll be giving a in it, I'll be giving a to it, and then I'll be giving b to it, then I'll be giving c to it, not c, x, and then I'll be giving y to it. After that I'll be giving what, I'll be giving n to it. Okay, once I have these values, in the calc function, what I'll do is I'll see the change. Okay, I'll see the change that is long, let's say x2 will be what, let's say a2. Okay, let's say a2 long a2 will be what, a2 will be a minus x, that is the difference that is x is having. Then long b2 will be what, b2 will be b minus y, right, this will be b2, this will be my b2. So what will I do now, is that I will see which is the minimum, right? You could have done it that way also, you can do it in this way also. Okay, basically we can do it this way, otherwise you can take the minimum also, that is also possible. Like there can be various approaches. What I'll be doing for this is, after this I will check what is the minimum. Okay, so I'll check which is the minimum among a2 and b2. Okay, which is the minimum height that I am having currently. Okay, so which is the minimum height, I'll first of all reduce that minimum height. Okay, I'll first of all reduce, okay, not this, like among a2 and n. Okay, a2 and n, which is the minimum, right? I will try to find which is the minimum among a2 and n. Okay, why among a2 and n? Because I'll check that whether I can reduce this a2 part or not. If I can reduce it, then I'll definitely reduce it, right? So n minus is equal to what, mi, minimum, right? This is what I will do. Then I'll take another minimum from b2 and n. Okay, whichever n is now left, and then what I will do is I'll simply reduce my n again by mi, right? The minimum that I could reduce, after that I'll simply return a cross b. Okay, this is what I will do, right? Let me try and copy the test cases. Meanwhile, if you have any doubts up till now, so you can just ask them in the comments. I'll now be looking at your doubts. Okay, I'm still waiting for you guys. No problem if the comments are reaching late. Okay, I'm looking at your comments. Our comments are reaching late to you. Return, okay, another silly mistake. Return, I think now this should work. Hundred, it is giving me 100. Why it is giving me 100? Why 100? Okay, I have not taken n as an input, man. Let me take n also as an input. Okay, let's now check if it works or not. 196. Am I doing something wrong here? Sorry, calc function दोबारा बता दो. Yes, I'll be telling you about this. Just wait a second, for I am getting some error here and there. Let me see if I am taking any input wrong or anything else. Okay. let's try and have a look what could be going wrong with this. Okay, let me see what can go wrong with this function. Basically what I'm trying to do is uh, in this function, basically what I'm doing is I'm just storing, okay, I'm just storing my answer. So the first jump that I will have to take is a minus x. Okay, the maximum that I can reduce from a is a2, that is a minus x. The maximum that I can reduce from y is b minus y. And now I will check that whether it is possible for me to reduce a by a2, right? The a that is above x is a2, right? A that is above x is nothing but a2, right? So I need to check that whether for me it is possible or not to reduce a, right? After reducing this, I'll reduce also, after reducing this, I'll reduce my a as well by this much number of times, right? And by after doing this, I'll reduce my b as well by b by mi, right? I'll reduce my b by mi. Is this part clear to everyone or not? Is this part clear to everyone or not? Like instead of doing it that way, I just made a function in which what I'm doing is basically what I'm doing in this function is what I'm doing in this function is I'm just taking a2, which is the maximum that I can reduce from a. b2 is what I can reduce from b. So I'll check if I have what is the minimum number that I can reduce, whether I can reduce a2 from a or I can reduce n from a. Whichever will is the smaller, that is what I'll be reducing, right? Whichever will be the smaller, I'll be reducing that. I'll simply be reducing that, and after that I'll reduce that part from a and that part from n. Then with whatever n is left with me, I will take out that minimum, and once I have it, so I'll check that whether minimum is b2 or n, the new n, and I'll reduce that much from b and n, and in the end I'll simply return the product, right? Is this much part clear to everyone? Is this much part clear to everyone? Just quickly tell me so that we can move ahead. 70, 77, 177. Yeah, right. Now we are getting the correct output. Actually, I just forgot to reduce a and b. That is why we were getting the wrong answers. Is this part clear to everyone? Is the function clear to everyone? Actually, what I was trying to do. Is that part clear to everyone? Just quickly tell me. Okay, I've submitted the problem. Is that part clear to everyone or not? Just quickly tell me. Just quickly tell me in the comments. It got accepted, right? You can see that it got accepted. Now let me show you again. What I will be doing is, let me increase the size. Got it, sir? Yeah, got it. Basically, you'll be taking a, b, x, and y, and n. Then I've made a function for calculation. What I'll be doing is, first of all, I'll be checking that. Let's say I try to, first of all, you can take the maximum minimum, like you can either observe a or b as max also, that will also be perfectly fine for you. But this is what I have tried to do. Let's try and make it, if you want to try, so you can instead of doing that, you can, if you say that a is greater than b, greater equal to b always, then you do not need to do this. Okay, what you will be doing is, I'll be checking a2. What is the a2? It is a2 is the maximum that I can reduce from a, and b2 is the maximum that I can reduce from b. Then I'll check that is what is the minimum that I can reduce. Either I can reduce a2 or I can reduce n, right? Whichever is the minimum, I can reduce it, and from that part I'll be reducing it from a and n. After that, I'll be checking what is the minimum availability of n, that is that I can reduce. I can reduce b2 or I can reduce n. What is the minimum, I will be reducing that. And once I've done that, so I'll update my b and n accordingly, and I'll return it. Okay, so this was the problem. Now moving on to the last part. So today again we discussed 3 greedy problems, and one was a problem, another was a b problem, and another was a b problem, right? So this is what we discussed today, 3 problems. And if you like the video, if you are watching the recording, you can do what, you can like the video, and you can consider subscribing the channel, and you can share it with your friends, or colleagues if you like our explanation. Okay, so this is the Code Era channel. Here we post CodeForces, CodeChef and LeetCode editorials. And did you guys understood it? Just quickly tell me, is everything clear to you? Did you guys enjoy it and did you understood everything? Just quickly tell me that. Only then I will be ending the stream. Okay, is there any doubt from the from that part, or is everything clear to all of you? Right, is everything, all the three problems are clear to you? All right, all the three problems are clear. Just quickly write a +1 or +1 if everything was clear and this session was helpful to all of you. Okay, was this session helpful for all of you? I hope that it was, right? Just sir enjoyed it a lot. So okay, let's meet tomorrow. Let's meet tomorrow 5 p.m. Okay, with some more problems, some more greedy problems. So this was the I think the this was the fifth session. So we'll have two more sessions after this on greedy, and then we'll be gradually covering more topics. So we'll be covering in breadth first. Okay, enjoyed sir, clear. Okay, so that's it for today, and you can consider sharing it with your friends if you